Hello viewers, welcome back to class. I'm super excited to have you back to class again. Welcome to Master Builders Online Academy. Now, if you are visiting this page for the very first time, or you have been with us but you have not subscribed to this YouTube channel, please consider subscribing to this YouTube channel and ensure that you turn on the post notification bell so that anytime we upload my new content, you will be notified. And also, don't forget to like this current video, share this video, and make your necessary comment at the comment section. In fact, the comment section is actually made for you to ask your question, suggest, or practically appreciate the knowledge you gain via the particular video. And to learn more about this video, you can check the description below. But listen carefully, our policy here is that you must not skip any part of this video for your own advantage, because by so doing, you may skip the very important part that will have made you gain mastery over this aspect of this lesson. So do not skip any part of this video and ensure that you avoid every unnecessary distractions anytime you are set to watch and to learn new concepts from our page. And finally, if there be any part in this video you do not understand, maybe when you watch it for the very first time, please guys, you have the singular opportunity to replay the video over and over again until you gain mastery over this aspect of this lesson. So guys, what do we have on the board in this new phase? We have differentiation of functions. And now this is the second lesson we are having on differentiation, which we have as standard derivative. Listen guys, it is very easy for you to gain mastery over any topic and any course as far as your profession is concerned. All you need to do is to understand principles, and in this lesson I'm going to be giving you the basic principles that will make you outstanding in this course, and that's why you must not skip any part of this video. What are these basic lessons? Listen carefully. For you to gain mastery over some aspect of life, you must understand principles. Why? Because when you understand principles, you become a principal. And equally, when you understand boundary conditions, you will not overstep your boundaries. So in this lesson, you seek to understand the principles and equally understand the boundary conditions so that you will not overstep your boundaries. Now guys, let's get to work. Now on the board, we are talking about differentiation, and we said that differentiation is the rate of change. Now what do we mean? And practically most people used to know differentiation as dy over dx. Of course, if I am given a function can be given as y or f of x. Any function in differentiation can either be given as y equal to a function of x, or f of x is equal to a function of x. And from here, I can obtain my derivative, just as we have standard derivative now. Alright? So now what is differentiation? If I have a function like this, differentiation or the derivative of a function is given in three forms. The derivative of a function is given in three forms. First, you can be asked to find y prime, which is dy over dx, or you are asked to find f prime of x. This is also the same thing as dy over dx, or you are asked to find dy over dx. Now, these are the three notations that differentiation questions can come in, or differentiating any function. So listen, if you are given any function, the question will either ask you to find y prime, f of x prime, or dy over dx. And equally, being for the fact that we are looking at objective question, you can also equally be asked to find the first derivative. So what we have on the board is what we call first derivative. So for differentiation, the three notations for first derivative of any function is what we have on the board. So you can be asked to find y prime, f of x prime, or dy over dx. All means the same thing. And what it stands for is the first derivative. So in the next lesson, we will be looking at higher derivatives, where you have second derivative, third derivative, fourth derivative, and nth derivative. But understand principles. So your question can either come as this, or this, or find the first derivative of the given function. So if this is understood, let's get to work. Now on the board, in our previous lesson, we looked at the different functions, and these are the basic functions in mathematics that we have here on the board, which we are quickly going to look at very shortly. All right. So now on the board, the first thing that we have here is x raised to the power of n, and understand that this is the column for serial number, which we equally have this way, and which we equally have in this way. All right. So first, we are asked to differentiate this. All you need to do anytime you are differentiating x raised to the power of n, of course, we already have that this is y prime or f of x or dy over dx, which I have already explained here. All right, are we there? Now, to find the derivative of this, all you need to do is to bring down the power of x to serve as the coefficient of x, then pull down the power. Now, anytime you differentiate any polynomial function, you must ensure that you reduce the power by 1. In other words, remove 1 from the existing power. So this is what we have. Equally, anytime we have, in this case now, we find out that the polynomial functions have a coefficient. The polynomial function here has a coefficient. And what do you do? What you simply do, you will always take the power to multiply the coefficient. So the difference between this and this guy is that the coefficient of this is 1. The coefficient of this is 1. But here now, the coefficient of this is more than 1 because A, where A, you need to understand that A here is equal to constant, which can be either positive value or a negative value. So when I differentiate this, all I do is to use this power to multiply the existing coefficient. Then I will have A multiplied by n, x raised to power n minus 1. Understand that anytime you differentiate polynomial functions, the power will always come down, then reduce the original power by 1. Then the next thing we are quickly going to do is that we have ax. In this case, understand that the power of x here is 1. In mathematics, you know that it is highly prohibited for us to have either 1x or x raised to power 1. Of course, you know that this can be 1x raised to the power of 1, which is equivalent to x. So we accept it this way. So anytime you have x, we are either it shows that we have a coefficient of x to be 1 and the power of x to be 1. Now, if this is understood, this is the coefficient of x as a. So anytime you differentiate x raised to the power of 1, you will have only the coefficient left. But understand that this one will not be here. But let me put it here for the sake of emphasis. So understand that anytime you see x without a power, it means the power is 1. And anytime you differentiate x raised to the power of 1, the s disappears, leaving only the constant behind. If this is understood, then we move to the next one. Now, we are differentiating all of these functions with respect to x, as we all know. Now, this function we have here is without x. Any function that you are differentiating with respect to x that does not contain x, that is to say that function is termed a constant, and anytime you differentiate a constant, you have 0. So when you differentiate a, you have 0. This is it. Then also, when you differentiate exponential x, you have exponential x. Now, when you differentiate exponential ax, now the difference between number 5 and number 6 is that number 5, the coefficient of x is 1, but in number 6, the coefficient of x is more than 1 or less than 1. A can be positive or a negative value. It can be -3, -4, or 3, 4, 5. So it shows that A is more. All you just need to do is to bring down the coefficient of. What's the coefficient of x here? The coefficient of x here is A. Then you have ax. Now understand that in this case, the coefficient does not reduce. Understand that anytime you differentiate exponential function, the coefficient does not reduce. Then if that is understood, when you differentiate sine, you have cos x. When you differentiate cos x, you have minus sine x. When you differentiate sine x, you have sec squared x. This is it. So when you differentiate this, you have sec x tan x. When you differentiate cot, you have minus cosec square x. When you differentiate sec x, you have minus cosec x dot cot x. So these are standard derivatives. So you can be given this as a question. Your answer is this. Alright? Now when you differentiate x raised to the power of 1 over n, this is what negate a fractional power, which can either be what the root of x, n root of x. Is that right? Yes, this is the same thing as n root of x. Okay? So for this case, I can decide to have this as x raised to power 1 over n or root xn. This is the same thing as this. So when you have square root, when you initiate this, you have 1 over n multiplied by what? 1 over the square root of n x raised to power n minus 1. This is what you have this to be. So when you differentiate this, you have this 1 over n. All you need to do, bring down the power, reduce the power by 1, and you are going to have something of this nature. Then, when you differentiate 1 over n, your answer becomes negative 1 over x raised to power n plus 1. So this is what you have when you differentiate. Then when you differentiate this, you have 1 over x log a. When you differentiate this guy, when you differentiate log a base x, log s base a, you have 1 over x ln a. When you differentiate ln x or this, you have 1 over x. Anytime you differentiate ln x or you differentiate log x exponent base e, you have this. Then when you differentiate this, all you do is that you see that the difference between 17 and 7. The difference between 17 and 7 is that for 7, the coefficient of x is 1, but for 17, the coefficient is 8. So when the coefficient is more than 1, the coefficient will always come out. Then when you differentiate sign, you have cos ax, angle remains. When you differentiate cos, of course, you know that you're going to have a negative result. Then the angle, which is the coefficient of x, will come out. Then you now have sine ax. When you differentiate tan x, the difference between 19 and 9 is the coefficient of x. So we equally have a sec square ax. Then when we differentiate this guy, we have ax ln a. Anytime you differentiate this, you have ax ln a. And when you differentiate this, you have kx ln a. Then now, if we have sine inverse of x, when you differentiate sine inverse of x, guys, this will have given us 1 all over the square root of 1 minus x squared. So anytime you differentiate the sine inverse of x, this is what you have. Then the same way, when you differentiate cos inverse of x, cos inverse of x, you will have negative 1 all over the square root of 1 minus x. The difference between this and this is always negative. Then when we differentiate tan inverse x, then this will have given us 1 all over 1 plus x squared. These are some of the basic standard derivatives that you need to understand. Please, you must ensure that you understand this particular table very, very well. I repeat, very, very well before you will slide down to the next video where we'll be looking at direct functions. Are you there? Differentiation of direct functions. Now guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when being uploaded. So guys, check the description below where you will find the link to the next lesson. See you guys in the next video.